Okay, now recording. Okay, so I'll just make some quick comments about the test and where we are going. So we've had 4 exams now. You should have gotten your exam score back from me. If you didn't get it, let me know. I sent out a video on the solutions also, so you can double check your answers there. So we just have 2 tests left, exam 5 and exam 6. I will not be going according to this schedule anymore. The most likely scenario I was going to think of from here on out is I think I can just do 1 section a day, and that is enough all the way through. So here we are. I did some of 9.2 last time. My game plan for this week was just 9.2, 9.3, 9.4, 9.5, just 1 section a day. Okay, and then that would lead us to 10.1, 10.2. Next week, reminder, we actually have a shorter week next week. The 22nd is a flex day. So I'm thinking most likely not having a test even next week, but the week after on Thursday, the 29th. Okay, so we just got started with the new stuff. So I did a little bit of 9.2 last time. I'll do more today. So if I do 1 section a day, literally it'd be 9.2 today. This is this week, the rest of chapter 9. So Tuesday, Wednesday, Thursday, Friday, we'll see how it goes. Okay, and then next week, 10.1, 10.2, but I think it might be a little bit too fast to give you the test on Wednesday. It would have been okay if I didn't have that flex day, but since we have that flex day, I don't want to rush that. So most likely we'll have the next test on Thursday the 29th. And then we have 3 weeks for our last exam. So I'm basically using up our buffer days. That's sort of where we're headed. Okay. All right, and then that's it. Then our final exam is the first day of finals, Monday the 24th. You'll get 2.5 hours to do the final exam, 11:10 to 1:40. Okay. So that's where we're headed. And I gave you a lot of formulas already from 9.2. I'll go back and give you those again. And that's our game plan for now. Okay, so any questions about the last exam, where you stand and what's happening? Remember, you get to drop 1 exam, but only 1. If you skip an exam, it goes as 0 in my grade book. But remember, you get to drop 1 exam, but only 1 exam. Okay, so you can't skip a second exam. The second exam will be 0, and it has to stay 0 from then on out. Okay, so again, I won't set it in stone yet, but the most likely scenario is the next exam will be Thursday the 29th. Okay, and right now the game plan is 1 section a day, 9.2, of which I started last time. And then tomorrow 9.3, Wednesday 9.4, Thursday 9.5, plus a quiz. Okay, next week we only meet Monday, Tuesday, Wednesday. Thursday, there's a flex day, so we're not meeting. Okay, so any quick questions about that, please? All right, so let's get started with today's stuff, 9.2 and the corresponding formulas. And you definitely want to put all these on your next cheat sheet. All right, so we had all the double angle formulas. I did some problems already with them on page 611. Sine of 2 theta equals 2 sine theta cosine theta. Cosine 2 theta is cosine squared theta minus sine squared theta. Tangent of 2 theta is 2 tangent theta divided by 1 minus tangent squared theta. Double angle formulas. There are other variations of the cosine of 2 theta. Page 613. We are cosine of 2 theta, 2 cosine squared theta minus 1. You can also write number 2 as 1 minus 2 sine squared theta. Do a little bit of algebra, you get number 3, cosine squared theta is 1 plus cosine 2 theta over 2. And number 4, sine squared of theta is 1 minus cosine 2 theta over 2. Okay. And then we have the half angle formulas. Okay, although 1 and 2 are just variations of 3 and 4 there. Okay, now 3 and 4, these are the ones that you'll see quite often in calculus. So I'll be using those more often. Basically, if you take the square root of number 3 and number 4, you end up with these guys here. And it's a plus or minus because when you take the square root, there's a plus or minus. Okay, and number 3 is a little bit different. You can actually survive without number 3. Number 3, you can actually take the ratio of sine and cosine. In other words, take number 1 divided by number 2. Sine of S over 2 divided by cosine S over 2, and that gives it to you. And you can use some algebra to show that, that's what you get. But it's there. You can use it if you wish. All right. Okay, the text goes over proofs of all these. You can look at it or not. We just want you to be able to use them. Okay. So here we go. So last time I left off with part A and B of problem, something like problem number 9. Okay, and I'm going to go back and do C and D now. Okay, so 9.2, number 9. We're given sine of theta is 3/4. And theta is between pi over 2 and pi. That means we're in quadrant 2. Okay, and let's see. We came out with cosine theta was negative radical 7/4, I believe. So you can look back in your notes last time. I think that's where we were. We can double check that. If I square this, I have 9/16. Square that, that's 7/16. Add them up, you get 16/16, which is 1, right? That's what we have. All right, so sine of theta over 2. Cosine theta over 2. First, let's see what's happening. For number 9, theta is between 90 and 180. Okay. Now, what is going to be true about theta over 2? Okay, so well, if I divide by 2 or take half of each of these, okay, so half of this is pi over 4, half of this is theta over 2, half of this is pi over 2. It basically means theta over 2 is between 45 degrees and 90 degrees. I'm in quadrant 1. So I want the positive of these. Okay. So sine of theta over 2 is positive square root of 1 minus cosine theta over 2. Cosine of theta over 2 is the positive radical 1 plus cosine theta over 2. And by the way, page 616 has a very nice summary of lots of formulas. So if you want to put all of this stuff on your next cheat sheet, and that's a lot of stuff already. So if you're going to write it, you might want to write fairly small, I guess. Okay, and those product of sum and sum of the form, we'll get that next time. But there's a lot of formulas here. Okay, so by formula, this is square root of 1 plus cosine theta over 2. Whoops, sorry, 1 minus. Got it wrong there. It should be a minus there. Minus. So radical 1 minus a negative radical 7/4 divided by 2. And double negative 1 plus radical 7/4 divided by 2. I'm going to let you leave it like that. You could do some more stuff. It's already so bad. You got a square root inside a square root. So we'll just leave that alone. Okay. Yeah, cosine is the one that has a plus. So square root of 1 plus cosine theta divided by 2. So 1 plus a negative radical 7/4 divided by 2, which is the same thing as this, except there's a minus sign. So radical 1 minus radical 7/4. divided by 2. And I'll let you just leave it like that. So yes, you could do more, but nobody feels like doing that, right? Okay. All right, so that's how to do the rest of 9. Okay, now 13 and 15, use an appropriate half-angle formula to evaluate each quantity. Okay, so 13 and 15, 15 is in degrees, 13 is in radians. I'm guessing you're less comfortable with radians, so let me do the radians one. Okay, so 13, sine, cosine, and tangent of pi over 12. All right, pi over 12 is half of pi over 6. 1/2 of pi over 6 is pi over 12. So again, I'm in quadrant number 1. So that's nice at least. All right, so I'm doing sine of pi over 6 divided by 2. Pi over 6 divided by 2 is pi over 12. So it's the square root of 1 minus cosine pi over 6 divided by 2. So half angle formula number 7 there. Sine of theta over 2. And again, in this case, it's a positive square root of 1 minus cosine theta over 2. And cosine of theta over 2 is the same thing, except it's square root of 1 plus cosine theta over 2. Okay, so pi over 6 is 30 degrees. So go back to my unit circle. 30 degrees. Cosine is x coordinate. X coordinate is radical 3 over 2. Square root of 1 minus radical 3 over 2 divided by 2. Okay, and that's actually it. I'm going to clean this up a little bit. You can make it a little bit nicer if I multiply top and bottom by 2, because it ends up looking like this. So the bottom is radical 2 times radical 2 is just regular 2. And this would be the square root of 2 minus radical 3. Like that. B asks for the cosine of pi over 12. It's the same formula, except it's a plus. So that's a 7C, a 7B. Yeah. Okay, so again, on page 616, there's a nice summary of lots and lots of formulas. You're free to put any or all of them on your cheat sheet. So square root of 1 plus cosine pi over 6 over 2. And the algebra is pretty much similar. That's radical 1 plus radical 3 over 2 divided by 2. Once again, multiply top and bottom by 2. 2 over 2. So you get the same thing as this, except it's a plus. So square root of 2 plus radical 3 all over 2. And then you can just leave it like that. You can punch it in a calculator if you feel like it. I don't feel like it. You probably don't feel like it. So we'll just leave it like that. Tangent is the ratio of the two. So I'm not going to use the formula. We know it's sine over cosine. I'll just take this answer divided by that answer. And we already know that the 2's cancel out, right? So just that divided by that. They both have square roots. So it's a little bit easier to write the whole thing as one square root. So I'm going to write radical 2 minus radical 3 over 2 plus radical 3. And you can just leave it like that. Okay, so that's how 13 goes. And go back and do my focusing thing. All right. Okay, then 17 through 24. They give you those triangles, and they got some double angles and some half angles that are there. So, right. Let me just check all the odd ones that you have to do are just the 3, 4, 5 triangle. The even ones are the 7, 24 one. So it looks like we just have to worry about the 3, 4, 5. Okay, so let me do some double angle, and I'll do some half angles for those. Okay. So let me quickly draw the picture. We got 3, 4, 5. Theta and beta. Yes, for the sine of 2 theta. All right, so in order to do this, let's get everything that we need here. So sine of theta is opposite over hypotenuse, right? Cosine of theta is adjacent over hypotenuse, 4/5, right? All right, so I need the sine of 2 theta. That formula is 2 sine theta cosine theta. See if I can find it for you. That's 6a. 6a there. You just pick the right formula, essentially, for all these ones. So 2 sine theta cosine theta. So 2 times sine of theta was 3/5. Cosine of theta was 4/5. So 2 times 3 times 4 is 24, divided by 5 times 5, which is 25. B, cosine of 2 theta by formula is cosine squared theta minus sine squared theta. Cosine, so cosine of 2 theta, that is 6b right there. So essentially, you're just looking at all these formulas and trying to pick the right one that fits the pattern that we have. Okay, those ones at the bottom, by the way, like 8 and 9, we're going to do that tomorrow. Product to sum of the product formulas, all that stuff. Okay. Okay, so cosine squared theta was what? 4/5 squared minus sine of theta is 3/5 squared. So that's 16 over 25 minus 9 over 25, which is 7 over 25. Okay. And then tangent of 2 theta, sine of cosine. So sine of 2 theta divided by cosine 2 theta. So 24 over 25 divided by 7 over 25. We know what happens in 25s. Forget about it. 24 over 7. And that's it. All right, now I'll show you 21 half angle formulas, right? 21, sine, cosine, and tangent of theta over 2. These are acute angles, first quadrant. So in the formulas, I don't have to worry about plus or minus, they're all plus. Okay, so again, I'm going to use 7a, 7b, and I don't really need 7c. Once I have A and B, I just do the sine divided by the cosine, right? Right, so here we go. 21 A sine of theta over 2. So by formula, 1 minus cosine theta over 2. So what was cosine theta? 4/5. 1 minus 4/5 divided by 2. 1 minus 4/5 is 1/5. 1/5 divided by 2. Okay, not sure if I taught you this trick before, but this 5, you can slide down with the denominator 2. It's basically 5 times 2, so radical 1/10, or 1 over radical 10. Okay, so a little timeout here. If you ever have A divided by B over C, you can just slide the B down like that, A over BC. If you want a justification of that, remember, if you divide by C, you multiply by 1 over C, right? Dividing by C is the same as multiplying by 1 over C, so you have A times 1, A over BC. All right, so 1 over radical 10. Okay, part B, cosine theta over 2. 1 plus cosine theta over 2. 1 plus the same thing, 4/5 divided by 2. 1 plus 4/5 is 9/5 divided by 2. Same thing, slide the 5 down. Square root of 9 over 10, or 3 over radical 10. All right, then tangent is just the ratio, sine over the cosine. That divided by that. Okay. Tangent of theta over 2. Sine theta over 2 divided by cosine theta over 2. So 1 over radical 10 divided by cosine of theta over 2, 3 over radical 10. 1 over radical 10 divided by 3 over radical 10. You know the shortcut. So 1/3. And there we go. All right. Let's see, how do you do something like 25, 27? Use the given information to express sine of 2 theta and cosine 2 theta in terms of x. So how do you do that? So we have to do 25 and 27. 27 definitely looks harder. So let me try to do 27 for you, and you do 25. Fortunately, those are what? First quadrant angles. Theta is between 0 and pi over 2. So that helps. Okay, so how about I try 27? X minus 1 equals 2 sine theta. So if I divide both sides by 2, I have sine of theta is x minus 1 over 2. Right? And we're in quadrant 1. All right, now I could do sine squared theta plus cosine squared theta equals 1. I'm afraid that might get quite messy. So let me use the right triangle approach for this. I mean, you got to know both ways anyway. So how do you do that? Go like this. Okay, sine is what from SOHCAHTOA? SOHCAHTOA. Sine is opposite over hypotenuse. So opposite is x minus 1. I'll write it slanted or sideways. And hypotenuse is 2. So here's the adjacent side. I can't call it x, so how about I call it y? Right? X minus 1 squared plus y squared equals 2 squared. X squared minus 2x plus 1 plus y squared equals 4. So all these guys over. Y squared equals, well, let's see. How should I do it? 4 minus 1 is 3, right? And both of these will change sign. So it's plus 2x minus x squared, right? Okay, x minus 1 squared, x minus 1 times x minus 1 is that. Y squared 4. Move that over. 4 minus 1 is 3. When x squared moves over, it becomes negative. And when the negative 2x moves over, it becomes positive. Okay, so y is just square root of 3 plus 2x minus x squared. Okay, no need for plus or minus. These are distances. We're in the first quadrant. So we have what we want. Okay, so finally, I'm ready for cosine of theta. So cosine is adjacent over hypotenuse. So it's this weird square root thing divided by 2, right? So radical 3 plus 2x minus x squared all over 2. And there we go. Now I'm finally ready because it says find sine of 2 theta. So formula is 2 sine theta cosine theta. Formula 6a, right? Just pick the right formula. 2 sine of theta is that thing. Cosine of theta is this weird thing. Radical 3 plus 2x minus x squared over 2. And how can I clean it up? I can cancel these 2's out maybe, and that's about it. Okay. Maybe I'll write this as x minus 1 over 2 times that stuff. Okay, so how about x minus 1 over 2 followed by square root of 3 plus 2x minus x squared, like that. Okay. And then cosine 2 theta. Use the formula. Cosine squared theta minus sine squared theta. And that's formula 6b. So cosine squared, where'd it go? This thing? Radical 3 minus 2x minus x squared over 2 squared minus x minus 1 over 2 squared. Well, the denominator is going to be 4, right? 2 squared, 2 squared. If I square this, you just take off the square root, right? You got that 3 minus 2x minus x squared stuff. 3 minus 2x minus x squared minus parentheses x minus 1 squared, x squared minus 2x plus 1. So how can I clean that up? So I'm going to have a negative x squared and another negative x squared, so minus 2x squared. Negative 2x minus a minus 2x, they cancel out. Then I have 3 minus 1, which is 2. So it looks like that's it. Okay, I have to turn the paper over, so let me do my focusing thing real quickly. What time is it? 1:45. See. And here. And then this column here. Usually I get about 3 columns for one sheet of paper. Okay. We'll turn the paper over. Okay, exercise 29, 32. Express each quantity in a form that does not involve powers of the trig functions. Okay, so if they've got fourth powers or something like that, write it so that there's no exponent like that. Okay, so how do I do that? So in 29, sine to the fourth of theta. Object is a writer without any powers. Okay, so what you do is this: sine to the fourth is sine squared, right? And now I use the formula for sine squared of theta. And they don't seem to have it here. It's an alternate version of what we had there. Let me go back. Number 4 there. So now that I'm thinking about it, they don't give you every formula here. They seem to have left some of them out. So I'm going to use number 4. Sine squared theta equals 1 minus cosine 2 theta over 2. Squared. Okay, so the bottom's 4. Top is 1 minus 2 cosine 2 theta plus cosine squared 2 theta. All right, there's no power here, there's no power here. There is a power here that I have to take care of. So I have to use a formula for cosine squared of some angle. And they don't seem to show that to you on this again. So I'll have to go back and show you that. Equation 3 there. Page 613. Cosine squared of theta, 1 plus cosine 2 theta over 2, which basically means you double this angle. To go from there to there, you double the angle. So what is double 2 theta? 4 theta. Okay, again, let me distribute all this so we don't get mixed up. So 1 divided by 4 is 1/4. 2 divided by 4 is 1/2. So I'm going to write that as 1/2 cosine 2 theta. And then that's going to be 1 over 4. Okay. Cosine squared of 2 theta is 1 plus cosine 4 theta over 2. Like that. Okay, so 1/4 minus 2 divided by 4 is minus a half. Then I have cosine squared 2 theta divided by 4, that's 1/4. Then I use a double angle formula. Cosine squared of 2 theta is 1 plus cosine 4 theta over 2. Okay, so I just cleaned that up now. And there's so much here. Okay. This is going to be 1/8. 1/4 times 1/2 is 1/8. Just that. I mean, there's so much here, I don't feel like writing some more, so I'll just appeal to your arithmetic skills. 1/8 plus 2/8. 3/8. Okay, so again, this is 2/8. Here's 1/8, so a 3/8. Minus 1/2 cosine 2 theta. Yeah, I already took care of that. And that's going to be 1/8 cosine of 4 theta. That's what I got now. Okay, and that's what we want for the answer. There's no more exponent anywhere. Okay. Now, 31 looks like it might be harder, but it's really the same thing. Look at 29 and 31. 29 we just did was theta. 31 was theta over 2. It's just an application of the same formula. Which really means this. Now, since this formula works all the time, it has to work if I plug in theta over 2. Which means I just put theta over 2 here and theta over 2 here, and you essentially have it. So sine squared of theta over 2 is 3/8 minus 1/2 cosine of 2 times theta over 2 plus 1/8 cosine of 4 times theta over 2. We've established this as an identity. Sine to the 4th of an angle is all that. That works for any angle. Since it works for any angle, it has to work for theta over 2, which means change that to theta over 2, change that to theta over 2. And it distributes. So that ends up being theta, that ends up being 2 theta, and that's about it. 3/8 minus 1/2 cosine theta plus 1/8 cosine 2 theta. Okay, so that's that. All right. (33) I actually already did. You can look back in your notes for it. It says prove the double angle formulas. The trick was you replace 2 theta with theta plus theta. Okay. So if you look back in your notes, I already did A and B, cosine of 2 theta, tangent 2 theta. So make it cosine of theta plus theta for A. B, make it tangent of theta plus theta. All right, so that's what we got. Okay, then the only thing we have left, well, I say only, it doesn't mean we're close to being done. But for what was on tap for today was 9.2, 1 to 51 odd. The rest were proofs. Okay, so 35 to 51, prove that the left side and the right side are the same. Okay, I mentioned this to you before. When you have a proof, you put a line underneath the equal sign and then show that the left side and the right side are the same. So some of you wondering how come I lost points on the test. Okay, I told you to put that line when it's an identity that shows you you're not supposed to cross over from one side to the other. Okay, so when you have a proof, you must put a vertical line indicating you can't cross the left and right hand sides. And I'll demonstrate one for you now, then it looks like it's almost time to break. And then after the break, we'll do more. Okay, so 35. Cosine 2s is equal to, then I'll make 1 minus tangent squared of s over 1 plus tangent squared of s. Okay, prove that you have an identity. Anytime it says prove that you have an identity, for me at least, you must go like this. Yeah, I'll just go ahead and say I deviate from other instructors. Other instructors don't insist on it. I insist on it, and there's a reason for that insisting. That shows you're not supposed to cross until you get them to be exactly equal. Okay, so that's why some of you may have lost points on that on the exam. Okay, so on this side, I'll use the formula. And this side, why don't I just change everything to sines and cosines? Okay, so cosine of 2s by formula, cosine of twice an angle, 6b, cosine squared minus sine squared, right? Cosine squared s minus sine squared s. Okay, and maybe that's all I need to do on this side. Let's not work on this side. Okay, so I know tangent is sine over cosine, so 1 minus sine squared s over cosine squared s divided by 1 plus sine squared s divided by cosine squared s. Okay, so at least I got everything to be sine and cosine. All right, so what should I do next? I don't like this fraction. How about multiply top and bottom by cosine squared s? So go like this. Cosine squared s, cosine squared s. Distribute, 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 distribute. So cosine squared s times 1 is cosine squared s minus sine squared s. The bottom's the same thing, except it's a plus. Cosine squared s plus sine squared s. Aha. And can you see what's going to happen? How can this be the same as this? Well, that's the same as that. So the only way it's going to work is if this is 1. It is 1. So that's the key. This is 1, which means you're dividing by 1. But if you divide by 1, you might as well just forget about it, right? So cosine squared s minus sine squared s. And there it is. Now they're equal. Okay, but notice that barrier, right? I never crossed the barrier. Crossing the barrier means multiplying both sides by 2, squaring both sides, square root of both sides. Those are no-nos when you're doing proofs. Okay, so that's why we have the barrier there. All right, so it's time for our break as usual. So after the break, we'll do more of these, and that's going to do it for today. So from here on out, aiming roughly 1 section a day, unless we have a quiz, Thursday, then I might change that out. Okay, so let's break until 12:10, our usual time. Okay, folks, it's 10 after. We'll go and get started again. While I get set up, some other things to share quickly, again, since we do have both Starr and Mackenzie with us right now. Please take advantage of, Starr and Mackenzie's help. If you can get them to help you, by all means, please do so. That's what they're here for. They're here to help you guys out. Some of you are fine on exams. Some of you are kind of in between. Some of you are unfortunately not quite there. And while I lecture some more, Mackenzie and Starr, if you feel like it, you can put something in the chat related to when you might be available for help, if you wish. If you can't and you're not able to, that's okay too. And while I'm blabbing along, if all the rest of you want to chat back and forth between yourself and Mackenzie and Starr, you may, in terms of when can I get help. And don't wait until just before the test for help. It doesn't work to cram at the last minute. You want to be able to do stuff now. So even though you say, oh, we're not going to have a test for another 3 weeks or whatever, I'm not going to study until then. No, you shouldn't do that. You should study as we go along, because otherwise, it's very hard, especially in a math class, to cram all this material the last day and so forth. Okay, so I'm going to keep doing more problems. But if Starr and Mackenzie, if you wish to put something in the chat in terms of availability, that's optional. That's up to you. If your schedule doesn't allow for it, you don't have to. And then if the rest of you want to chat back and forth between yourselves and Mackenzie and Starr, you may do that while I lecture the rest of today. And that's what's going to happen for today. Okay. I wasn't going to give you an in-class assignment because it's too difficult, especially for proofs, to do that. So I'll do some problems and we'll probably end early. But please take advantage of Starr and Mackenzie. They're here to help you. Now some of you are saying, I'm doing great. Yeah, if you're doing great, fine. But some of you are kind of iffy, borderline, passing, not passing. Then please, use their services. That's what they're here for. They're embedded tutors, and Mackenzie and Starr are here to help you guys out. Okay, so I'm going to keep going. But if you want to put in the chat, so Starr and Mackenzie, if you wish, you can put something in terms of when you might be able to help students out, if it fits your schedule. But don't feel like you have to. And then other students, if you want to apply to it, that's fine while I keep lecturing from here, okay? So I did one proof, I'll do other proofs, and that's going to do it for today. Okay, now when you stop and think about it, problem 39, I sort of already did. Okay, that kind of looks like problem 29. Right, so that's that. 37 is just a variation of one of the formulas. In fact, I'll do that real quickly. 37. Cosine of theta equals 2 cosine squared, theta over 2, my bad, minus 1. This is theta over 2. Theta over 2. Essentially, you think of this as cosine of twice theta over 2. So the angle that I'm doubling is theta over 2. And one of the formulas for cosine of twice an angle is number 1 there on page 613. Cosine of twice an angle is 2 cosine squared theta minus 1. Two cosine squared of this angle, theta over 2 minus 1. And you're already done. Okay, so if you can't read what I have here, it matches this. Okay, it is the same. There we go with that. Okay. All right, so I'll do several others here. 41. Sine of 2 theta. Now, if you know you're going to work on both sides of the equal sign, you might want to leave yourself some elbow room to expand this out. 2 tan theta over 1 plus tangent squared theta. All right. Sine of 2 theta. In order for me to get on a match, this is double angle. These are single angles. So I better use the formula for sine of 2 theta. 2 sine theta cosine theta, right? And I'll try to show you as much as possible. So that's 6a, formula 6a there. And then the right-hand side, look at the denominator, 1 plus tangent squared theta. Recognize that one? 2b, tangent squared theta plus 1, or 1 plus tangent squared theta, secant squared theta. Well, I'm almost done. Let me write this. Tangent is what trig function over what other trig function? Sine over cosine, right? Sine theta over cosine theta. I've got a secant squared in the bottom. Secant squared in the bottom means what can I put on top? Cosine squared, right? Cosine and secant are reciprocals. Cancel, cancel, and you got them to match. 2 sine theta cosine theta. So again, there it is, a match. Okay, so again, ground rules, when you're doing these identities, put an equal sign, draw that line, which means you can't cross until you get them to exactly match. So statements like multiply both sides by 3 are not allowed. Square both sides, can't do it. Take the logarithm of both sides, not allowed. Okay. All right. Then let's see. About 45 looks pretty bad. One plus tangent theta over 2. 1 minus tangent theta over 2. Tangent theta plus secant theta. All right, that looks like a case where I better use the identity, tangent of theta over 2, which I haven't used yet. That looks like 7c. 7c, again, page 616 has a lot of formulas, but I'm just realizing it doesn't have them all. Okay, so tangent theta over 2, sine theta over 1 plus cosine theta, right? So 1 plus sine theta over 1 plus cosine theta divided by 1 minus, same thing, sine theta over 1 plus cosine theta. And what am I going to do on the right-hand side? How about just change everything to sine and cosine, right? If you're in doubt as to what to do on these identities, I have no idea what to do. Change everything to sines and cosines. So tangent is sine over cosine. Secant, 1 over cosine. So how about what? Sine of theta plus 1 over cosine theta. All right, that's about as good as the right-hand side is going to get, right? So now my object is to force the left side, make that look like that. Okay, so let me play the common denominator game, multiply both top and bottom by 1 plus cosine theta. 1 plus cosine theta, 1 plus cosine theta. So that's going to cancel this out and this one out, right? So I have 1 plus, oh, I'm sorry, 1 plus cosine theta plus, so 1 plus cosine theta times 1 is 1 plus cosine theta, right? Okay, and then this fraction times this, these cancel out, so I'll just have sine theta. And what do I have here? Same thing except a minus, right? So 1 plus cosine theta minus sine theta. Right? How do I get that to look like that? Almost seems hopeless. Well, let's try something. Okay. I mean, you'd say, how do I get that to match that? Well, I can force this to have that by multiplying by 1 plus cosine theta minus sine theta. Alternatively, I can multiply this side by cosine theta over cosine theta and then see what happens. All right, let's go ahead and try that. Cosine theta over cosine theta. All right, so if I distribute the top, I have cosine theta plus cosine squared theta plus sine theta cosine theta over 1 plus cosine theta minus sine theta times cosine theta. Okay, then on this side, I'll multiply by, let's see, by what I need essentially, which is 1 plus cosine theta minus sine theta, and then hopefully we get them to match. 1 plus cosine theta minus sine theta. 1 plus cosine theta minus sine theta. Okay, so even though we're not cheating per se, you are peeking at the other side. I mean, I am looking at this side and saying, well, if I'm going to get in a match, what can I do? Notice, even though I'm putting an operation down, I'm looking at the other side, but I'm not multiplying both sides by 2. I'm not, squaring both sides. So I'm only on this side. I am multiplying by cosine theta over cosine theta. So where did you get that from? I looked over here, but this is a valid step. I'm still only working on this side. Likewise, I said to myself, well, if we're going to get these to match, I better have the bottom the same. So I multiply by 1 plus cosine theta minus sine theta. Where'd you get that from? I looked over here and got it. But this is still operating only on this one side, you see. So it is still considered a valid step. It looks like I have to FOIL all this stuff out and see what happens. Okay, so sine theta times that, and then 1 times that. Okay, so sine theta times 1 plus sine theta cosine theta minus sine squared theta. Okay, and sorry, it's getting so long, I'm going to scroll down, so to speak. So instead of keep writing that way, I'm going to scroll down. then it's 1 times all these. But if it's 1 times all these, I just copy this, right? Because 1 times anything is just the same thing. So plus 1 plus cosine theta minus sine theta all over cosine theta 1 plus cosine theta minus sine theta. Okay, and now let's see what we can do. Cancel, cancel. I have 1 minus sine squared theta, which is cosine squared theta. Okay, and then I got in a match. Okay, so finally I got cosine theta right here. And I know what I'll circle these right here. That combination right there, 1 minus sine squared theta is cosine squared theta. So indeed, I do have a cosine theta, a cosine squared theta, and a sine theta, cosine theta. All over, same thing, 1 plus cosine theta minus sine theta times cosine theta. And finally, we got to be the same thing. So that one's quite involved. There's a lot going on in that one. Okay. All right, how about I do 47 for you? Two sine squared of 45 degrees minus theta equals 1 minus sine of 2 theta. See if I wrote it right. Okay, that looks kind of weird. Now let me use the formula here. 2 sine theta cosine theta. For now, maybe that's all I'm going to do. Okay, this is a sign of a difference. That looks like 5b. Sine of something minus something, right? Sine of the first, cosine of the second, minus cosine of the first, sine of the second. And it's being squared, unfortunately. Sine of 45 degrees, cosine of theta, minus cosine 45 degrees, sine of theta. And the whole thing is being squared. It's cosine theta. Okay, sine of 45 degrees is radical 2 over 2. Cosine of 45 degrees is also radical 2 over 2. So if I factor out the radical 2 over 2, I have cosine theta minus sine theta quantity squared. That's a theta there, sorry. Radical 2 over 2, radical 2 over 2. Factor out the radical 2 over 2. Now, what's radical 2 over 2 squared? 2 over 4, right? Or 1/2. They all cancel out, don't they? Radical 2 over 2 squared, radical 2 squared is 2, 2 squared is 4. So this is, square of this is 1/2, that cancels that. So I just have to square this. So cosine squared theta minus 2 sine theta cosine theta plus sine squared theta. Cosine squared theta plus sine squared theta, 1. And we have it. Except I ran out of real estate. So I'll just put 1 minus 2 sine theta cosine theta. This is all still supposed to be on the left side though. And they match. And you can do likewise for me. Some of you probably already noticed that, but if you find yourself running out of space on the left side, go ahead and just draw a box and say this is still part of the left side. You can do that on homework or quizzes or exams anytime you want. Okay, so we got them to match. All right, 51 is the last one, and then I'm done for the day, folks. So just tell you ahead of time where we're headed. For tomorrow, we have 9.3, so-called product to sum and sum to product formulas. They're variations of the sum and difference formulas. Okay, so just you can see ahead at 620. Put these on your next cheat sheet. And sum to product on 622. Okay. All right, so 51, and then I'm done for the day, folks, unless anybody has any questions. Okay, 51, tangent of alpha, tangent of beta, blah, 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 blah. Find alpha plus beta. Given that alpha and beta are first quadrant. Hint, compute tangent of alpha plus beta. Okay, so what do they mean by that? $51. Tangent of alpha is 1/11. Tangent beta is 5/6. And I'm not going to write it down, but everything's in the first quadrant. Right? Look at 51. Alpha between 0 and pi over 2, quadrant 1. Beta between 0 and pi over 2, quadrant 1. Right, so tangent alpha plus beta. Tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. And that formula is 5E. Tangent s plus t, tan s plus tan t over 1 minus tan s tan t. So let's see what happens. Tangent of alpha is 1/11. Tangent of beta is 5/6 over 1 minus the product of the two. 1/11 times 5/6. That looks real bad. How about multiply top and bottom by 66 to make it look much, much nicer. Okay, 66 divided by 11 is 6. 6 times 1 is 6. 66 divided by 6 is 11. 11 times 5 is 55. And this becomes 66 minus 11 times 6 is 66. 66 minus 5. 61 divided by 61, which is 1. So in other words, we have tangent alpha plus beta is 1. What first quadrant angle do you know of? Right? Where the tangent is 1. That's sine over cosine. That means both the x and y coordinates are the same. 45 degrees, right? Radical 2 over 2, radical 2 over 2. Or in radians, that's pi over 4. So alpha plus beta, which is what they were asking for, is pi over 4. So that's the idea behind that one. Okay, I'm done for the day, folks. So I'll do my focusing thing. If anybody has any questions, you can start asking them and putting them in the chat now. But once I finish this focus thing, otherwise we are finished. All that. And sorry, if you can't see this, it's the same as this. You see where it says equal. So I made a mess of that. Sorry about that, but that's the same as that. And this one, yeah, that was a pretty complicated one there. It's 47 and then 51 right there. All right, so that'll do it for today, folks. So schedule-wise, I don't think I see anything new in the chat, so that means that's about it. So again, we're aiming for roughly one section a day now. So just did 9.2, so tomorrow 9.3, 9.4, 9.5 plus a quiz. Okay, I'm not sure about the next test. I'm probably leaning toward not having it on the 21st, so most likely it'll be on what, Thursday the 29th. And we have time for it. Since I had so many buffer days, I'm going to start using them, so to speak. So I think if I do one section a day, I'm still going to be good in terms of what's happening. Okay, any last minute questions? Otherwise, we're done for the day, folks. Check. Okay, I don't hear anything. Mackenzie has something. All right, so everybody can look at that if they wish. And I think that's about it. Okay, so we're done for today, folks. So everybody have a good afternoon, and we'll see you next time. Okay, all right, bye, everybody. Thank you.